All right, so last semester we talked about triangle congruence, and we used things like side, angle, side, and side, 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 and angle, angle, side to show congruence. We have the same kind of thing for triangle similarity. Now notice we have to put a little squiggle at the end of these. So we have angle, angle, similarity. We have side, 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 similarity, and side, angle, side, similarity. You have to have the similarity squiggle after the name of each of these. Again, we're on page 9 in your notes. You have to have the squiggle at the end, yes. So for angle, angle, similarity, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So in this picture, I'm going to come in and label these angles. We're going to call this angle 1 and angle 2, angle 3 and angle 4. If angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4, then we have angle, angle, similarity. We also have side, side, side similarity. If three sides of one triangle are proportional, not congruent, but proportional to three sides of another triangle, then the triangles are similar. So if the fraction a prime over a is equal to the fraction b prime over b is equal to the fraction c prime over c, then we have side, side, side similarity. And finally, the last one that we have is side, angle, side similarity. So we're going to mix a little bit of both of the previous two. Two sides of one triangle are proportional, and the included angle is congruent to the included angle of another triangle. Then the two triangles are similar. So in this picture, if E prime over E is the same fraction, an equal fraction to G prime over G, and we're going to call this angle 1 and this angle 2. Angle 1 is congruent to angle 2. Then we have side, angle, side similarity. So three types of similarity there. Angle, angle, side, 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 and side, angle, side. All right. Let's practice using these to identify similar triangles and then to write triangle similarity statements, making sure to match up the corresponding congruent angles and the corresponding proportional sides. So we're going to prove these triangles similar if possible. So just like when we were talking about triangle congruence, there's a couple things that I am allowed to mark on the picture without being told. Does anybody know something on this first picture here, number 1, part A, that I would be allowed to mark without being told? Vertical angles, yes. So my vertical angles are right here at the center of the bow tie. Those are congruent to each other. And then I notice these little arrowheads on these lines. What do those arrowheads mean? It means parallel. When we've got those arrowheads, it means parallel. So they're never going to run into each other. So this right here and this right here are parallel. What'd you say? We're going to draw a Z-type shape here. Yes. So I want to connect those two parallel lines using one of these transversals. And it does not matter which one you choose. We only need one of them for this. You could do it both ways if you wanted to. But I'm going to connect those two using one of the transversals like this. And now tucked into these orange corners, I have congruent angles. So this angle right here down at D, and this angle up here at B. Does anybody remember what type of angles we call those? Alternate interior, yes. You could have drawn the Z the other way. That would have been fine. But I only need this much because what have I shown on the picture so far? Two pairs of congruent angles. So are these two triangles similar? Yes, using which type of similarity? Angle-angle similarity, yes. So using angle-angle similarity, we can say that these two triangles are similar. And now we're going to write our similarity statement. The order of the letters in the first triangle does not matter, but the order of the letters in the second triangle does matter, and it's based on your first triangle. So I'm going to say triangle. Let's name this one over here on the left first. I have points A, C, and D. What do you want to call this triangle? ACD. Sounds good. Triangle ACD is similar to triangle, and now I have to match up my corresponding congruent pieces. A does not have an arc mark on it. What is the angle on the other triangle that does not have an arc mark? E. E does not have an arc mark on it. Then we have C in the middle, right here. What does that correspond to on the other triangle? C. And then angle D has two arc marks. What does that correspond to on the other triangle? B. So triangle ACD is similar to triangle ECB. Beautiful. All right, let's go on and look at part B now. What's something I can mark on the picture without being told? Vertical angles, right here at L. Can we try that angle-angle trick again? Do I know about another pair of congruent angles? No. So I can't use angle-angle similarity. What are the other two types of similarity that we have? Side, 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 and side, angle, side. Do we know about all three sides on both of these triangles? No, because I don't know about this side, and I don't know about this side. So I don't know about all three sides on both triangles. So I can't use side, side, side. I'm going to have to try to use side, angle, side. So now I have to check to see, are the sides proportional? So I need to know, is one fraction equal to the other fraction? And we have to match up our proportional pieces, or the pieces that we think are proportional. Biggest to biggest, smallest to smallest. So I have this blue triangle down on the bottom. And I have this pink triangle up on the top. I have to match a pink side with a blue side. What is the biggest side on the blue triangle? 26. What's the biggest side on the pink triangle? 12. So I have to make a fraction out of 26 and 12. Does it matter which one I put on top? Nope. Let's put 26 on top. 26 over 12. You could do it the other way around. That's perfectly fine. And then we need to match up the other two sides, 10 and 18. I have to set up my fraction the same way I set up the previous fraction. So which one should go on top, the 10 or the 18? 18 goes on top. So 18 over 10. And then I grab a calculator. If you need to borrow one from me, please feel free. We're going to divide these. What do you get when you do 26 divided by 12? 2.16 repeating. Just the 6 repeating? Okay, no worries. And then what about 18 divided by 10? 1.8. Did those come out to be the same? So are the sides proportional? So are the triangles similar? No, these are not similar. Can't write a similarity statement because the sides are not proportional. Right. You guys ready to look at another pair? Let's look at another pair of triangles. Part C. Is there anything I'm allowed to mark in the picture without being told? Vertical angles right here at the center of the bow tie. Can I try to use angle-angle similarity here? No. Can I try to use side-angle-side similarity here? I can't try to use side-angle-side? Look at it closer, please.
Oh, yeah.
Yes. Side-angle-side I can try to use. I can't try to use side-side-side because there are two sides, a pair with one on each triangle that I don't know. So I know about those two vertical angles being congruent. So now I need to know, are the sides proportional? So fraction, question mark, is it equal to my other fraction? Biggest side to biggest side. Which sides are we matching up? 45 and 9. Let's do 45 over 9. We could do it the other way around. That'd be perfectly fine if you wanted to do 9 over 45. And then I have to match up my other two sides, the 30 and the 6. Which one has to go on top because of the way I set up the other fraction? 30 has to go on top. 30 over 6. What is 45 divided by 9? And 30 divided by 6? 5. Are the sides proportional? Yes. So are these triangles similar? Yes. Using which reason? Using side, angle, side. Now, if I just write it like this is wrong. If all I write is this, I'm saying that those two triangles are exactly the same size. I'm saying they're congruent. What do I need to add if I want to say they're similar? Yep, I need that similar squiggle next to it. All right, now we're going to write our similarity statement. Triangle. What do you want to call the blue triangle? FGE. Sounds good. FGE is similar, not congruent, similar to triangle. All right, so I have to make sure to match the pink triangle up with the corresponding pieces. When I look at the first letter F, that's here. That's at the end of the side that is proportional to 9. But it doesn't have an arc marking on it. So which angle would have to be corresponding to F?
R.
R, because it's at the end of the side that is proportional to 45 right here. So it has to start with R. We put the 45 and the 9 in a fraction together, and so that's what I'm looking at. There's an arc marking on this end, but F up here at the top is the peak of the side that touches the side that is proportional to 9, so it has to be R out here. All right, and then it goes down to G. What would that have to correspond to on the other triangle? S. And then E is the easy one because it's our vertical angle and it's congruent to the opposite side, to the vertical angle on the opposite side. So I can match up my corresponding congruent angles. So triangle FGE is similar to triangle RSE. All right. D. D looks a little bit weird. I have one triangle nested inside the other. I'm going to look at this little blue triangle, and then we will look at the much larger triangle that I'm going to outline in black. Oops, that's really tiny. So we have these two triangles here. Angle J is part of both triangles. It's the lower left-hand vertex of the blue triangle, and it's the lower left-hand vertex of the larger triangle. It is congruent to itself. We have angle J is congruent to angle J. That is our reflexive property. I'm going to move that up to the top because I want some room on the bottom. So I have an angle that's congruent. Should I try for side, side, side similarity here? No, what should I try for? Side, angle, side. So now I need to see, are my sides proportional? You've got to put that away and leave it. Put it away. Are these sides proportional? So fraction, is it equal to this other fraction? So I'm going to match up my corresponding sides. We have this side of the big triangle that is 66, and that would correspond to this side right here of the blue triangle, but I don't know how big it is. Do I have the ability to figure out how big it is? Yes, I know the whole thing is 66, and I know this much up here is 55. So how big is this part right here? Yep, 11. 66 minus 55 gives us 11. So we're going to make a fraction with 66 and 11. 66 over 11. Then we come down to the bottom side. I know that from J to R is 9. Do I know the corresponding length of the entire big triangle on the bottom here? No, but what can I do? Yes, I can add 9 and 39 together. And that'll give me what? 48. So 48 and 9 need to make a fraction together. 48 over 9. And now we're going to check to see if these are proportional. What is 66 divided by 11? 6. And 48 divided by 9? 5.3. Repeating or not repeating? It's repeating. Okay. Are those the same? So are these sides proportional? So are the triangles similar? No. not similar. We can't write a similarity statement because the sides are not proportional. Nicely done. All right, let's look at two more. What type of similarity should we try for on part E? Side, side, side. Yes. Let's try that. So are sides proportional? How many fractions do I need to set up? 3 fractions. How will I decide which pieces to match up? Yes, biggest to biggest, medium to medium, smallest to smallest. All right, so give me a pair of sides that I can match up. 16 and 12. Which one do you want to put on top? Sounds good. 16 over 12. Give me another pair of sides to match up. 12 and 9. How does this one have to be set up? 12 has to be on top, so 12 over 9. And finally, 8 and 6. So we do 8 over 6. And now we're going to divide each of those. What is 16 divided by 12? 1.3 repeating, or 4 over 3. What is 9 divided by 12? 1.3 repeating, 4 over 3. So those are equal. What is 8 divided by 6? 1.3 repeating, or 4 over 3. Are the sides proportional? Yes. So what reason can we use for similarity here? Side, side, side similarity. All right, let's name our left triangle first. What do you want to call the left triangle? JLK. Triangle JLK is similar to triangle. Now I have to pay attention, and this is where my colors come in handy. I have to pay attention to which pieces are coming together because I have to make sure to match up these proportional sides, and I have to make sure to match up my corresponding angles. So J, I notice, is at the corner where the blue and the green sides are coming together. Do you guys see that? Which corner is where the blue and green are coming together over here?
Q.
Q. So I have to start this with Q. All right, so then it goes J, L. That's going along the green side. So this would have to be Q to what? Q to M. So triangle JLK is similar to triangle QMP. Beautiful. All right, let's look at F. Should we try for side, side, side similarity on this one? Side, angle, side. So what do we have to try for? Angle, angle. Do we have at least a pair of angles? Do I have at least one pair of angles that are already congruent? Yes, I have a 90-degree angle here and a 90-degree angle here. I know that 44 and 47 are not the same, but those aren't the only ways that I could match up the angles, right? Maybe this angle right here, F, is congruent to this one over here. What do I need to do to figure that out? Yes. So I'm going to add 90 degrees and 44 degrees together. What is 90 plus 44? 134 degrees. And so then for this angle right here, I'm going to do 180 minus 134. And I get 46 degrees. Are these two triangles similar? No. I have one pair of corresponding congruent angles, but then the other two angles here are 46 and 44, which is not congruent to 47. So are my triangles similar? No. Yes. What about? How many degrees does all three angles in a triangle add up to? 180. So I added those two together and minused it from 180 to find that missing angle up at the top. Does that make more sense? Okay. We only have one pair of congruent angles. All right. There's just a couple more at the top of the next page that I want to look at. Same thing as right here. Part G, do we know any of the sides here? No, we don't know any side lengths. What do these arrows mean? It means parallel. So I have this little orange triangle here, and then we have the larger triangle that I'm going to outline in black. This triangle right here. Is there any angles that are shared by both triangles? Angle L. So angle L is congruent to angle L. That is our reflexive property. And then we have these parallel sides. Normally I want to draw a Z when I have parallel sides. Can I draw a Z here? Not really. But we have a different pair of angles we can look for. So I'm going to go across my parallel lines, and I'm still going to connect them with one of the transversals that touches both of them. You guys okay if we go across the bottom? So I'm going to connect them like this. So that picks out this purple angle right here and this purple angle right here. Those are not alternate interior angles, but that is one of the special angle pairs that we learned about last semester. Those are corresponding angles. They're in matching corners. Corresponding angles, and they are congruent. So now I have enough to say these two triangles are congruent, or similar, sorry. These two triangles are similar by angle-angle similarity. And now we're going to write a similarity statement. Let's call our first triangle PLQ. Triangle PLQ is similar to triangle P has no arc markings on it. What's the other angle with no arc markings? J. L is congruent to L, so what would have to come next? L, so JL, K. Because angle Q has two arc marks on it and angle K has two arc marks on it. So if I have parallel lines, but I don't have a bow tie shape, I don't have an X shape, I can't connect my alternate interior angles, but I still have these parallel lines, I can draw a connecting line between them. It kind of looks like a really big angle then, and that's how I find my corresponding angles. First thing I notice about part H is that these triangles are not labeled. So let's call this first one, let's see, we'll put A here at 59 degrees, B up here at 48 degrees, and C down here. Let's put E at 48 degrees, D down here, and F at 73 degrees. I see right off the bat that angle B and angle E are congruent. Is it possible that angle C, oops, not like that, that angle C is congruent to angle F or angle D? Yes. How would I figure that out? Yeah, we want to add our two angles together and then minus them from 180. So I'm going to take 48 plus 59. What does that give me? 107. And then I'm going to do 180 minus 107. We get 73 degrees. So this angle right here is 73 degrees. Well, that is congruent to angle F. So are these two triangles similar? Yes, using angle, similarity. So then I can say that triangle ABC is similar to triangle. A would have to match up with which angle over here? D. B matches up with E. So triangle ABC is similar to triangle DEF. Beautiful. All right, last one. What can I mark on the picture without being told? Vertical angles right here. What type of similarity should we try for here? We should try side angle side. All right, let's match biggest to biggest. 22 matches up with 11. So 22 over 11. Is that equal to, what else can we match up? 20 and 10. So 20 over 10. What is 22 divided by 11? 2. 20 divided by 10? 2. Are my sides proportional? So are these triangles similar? Using what? Using side angle side similarity. I can say that triangle, let's call this TWZ. TWZ is similar to triangle. Let's see, T is right here. It's touching my side that was proportional to 20. So what do I have to start my other triangle name with? Y. W was my vertical angle, so I need W next. So TWZ is similar to YWX. Nicely done. The homework that you guys picked up on your way in the door is due on Wednesday this week. Homework is due on Wednesday.